then today we're going to be talking about a new way of how to graph functions. So the normal way that we graph functions is we choose some x coordinates and then we find f of x, right? So in this case, we choose x to be -2 and we say f of -2 is -2 squared, so that's 4, and then we have a point, so then we plot it. And so we plot enough points and then we have our parabola, right? And we can draw our graph. But there are other ways to graph, and so one of these ways is to use graphs that we know, like x squared or x cubed or sine x, or any graph that we normally graph, and then look about how adding numbers in different places or subtracting them changes where the graph is. So let's all take a minute and get with a partner and graph g of x equals x squared minus 1. And so I want you to draw the graph and then also write your points for -2, -1, 0, 1, and 2. All right, let's get back together. Who can tell me what the points that they got were? So we have 3, we have 3, 0, -1, then we have 0, and 3 again. So if we graph this, we have 0, -1, 1, 0, -1, 0, and then 2, 3, and or -2, 3, and 2, 3. And so we see that it's the same as x squared except shifted down 1. And in this case, we subtracted 1. So from this, we can get a general rule that if I have some function that I know, so I know what x squared looks like. So let's say f of x is some function that I know how to graph. And then I added some number to it. So we'll call that number c. That means that when I graph it, we just shift f of x up c units. So if this was x squared plus 3, we'd shift this graph up 3 units. And so instead of 0, 0, we'd have 0, 3. So in this case, we had f of x minus c. So then we shift down c units. So if it's a plus, we shift up, and if it's a minus, we shift down. So let's take a second to do a practice one, and I want y'all each to graph h of x equals x cubed plus 2. And if you forgot, x cubed looks like this. So without doing the points, let's graph it using what we just learned. Awesome. So what you should have is you should have these points each shifted up 2. So one of the easiest ways to do this is to choose a point that you know. So we know that x cubed goes through 0, 0. So I just need to shift that point up 2, and then all the rest of the points. So my graph should look like this. So we see that it's the same curve and it has the same structure or the same shape, but it's just moved up or down depending on if we're adding or subtracting. So now there's another way that we can shift. We can shift left or right. So let's look at g of x equals x plus 2 squared now, and write the points for that. So we have x and g of x. So if we have x is -2, we plug this in here, and we have -2 plus 2, and that's 0, so then our g of x is 0. So -1 gives us 1, 0 gives us 4, 1 gives us 9, and 2 gives us 16. So if we graph this, we have -2, 0. I'm going to graph it in pink this time. So we have -2, 0. -1 is 1. 0 is 4. And then 9 and 16. We'll just draw it there. So we have the graph over here. So we can see that it is the same shape as x squared, which is something we can anticipate, but it's moved to the left by 2 units. So if we add on the inside, we move to the left, and if we subtract, we move to the right. So this can give us our new rule for adding and subtracting inside. So in the first case, we have our function and then we add a constant at the end. But in this case, the rule is if we have f of x plus c inside, so in the case of x cubed, we have x plus c cubed, or in the case of ln x, we have ln of x plus c. So if we have x plus c, it means we'll shift left by c units. And then if we have x minus c, we'll shift right by c units. So now let's do another example, so if you can get into partners. Let's do h of x equals x minus 1 cubed. So you remember from the last example what x cubed looks like. So let's take about 30 seconds to work together on that. All right, everybody look up here. So this is the original graph of x cubed. So we have x minus 1 on the inside, which means we need to shift right by c units. And in this case, c is 1. So we're going to shift to the right. So we know the point 0, 0 normally, so we want to think about how many units that's getting shifted over. So now we have 1, 0. So we'll have the graph that looks like this. So it's the same. It looks the same, has the same shape, we're just moving to the right 1 unit. So now let's think about how we can put these together. So if I have the graph f of x equals ln of x minus 2 plus 3, then I can draw the original ln of x, which looks like this. So the first thing that I can think about, this is 1. So we know 1 point, 1, 0. So we can think about first, let's move to the right, because we have a minus 2, so we move to the right 2 units. So we can first draw that. So now our point goes through here, and we have the same graph, just moved to the right 2 units, and then we need to move up by 3 units. So we can draw these 3 units, and our final graph will start here, and it'll just be like that. So it's the same graph, just shift it over 2 to the right, and then up 3. So now, let's get in groups and do 2 examples, and then I'll choose 2 people to come up to the board once you've talked together in partners. So let's do f of x equals sine of x plus pi minus 2, and g of x equals x plus 2 squared minus 4.